Hi, linear algebra students. This is an exercise that is almost at the end of the introduction section to linear transformations. First of all, you should be able to do this exercise. You should certainly have an attempt at it before watching the solution, pretty much. So if you didn't attempt this exercise at all, you should close this video and try the exercise on your own. I actually give you a lot of hint because, okay, so first of all, this is a May 2019 final exam question. However, in that exam, it was not written show that t is not linear. It was written prove or disprove that it's linear. So in other words, you didn't quite know. Now I'm kind of giving you a hint. It's not a linear transformation and you have to show that, okay? And I give you also another hint is to consider if t was linear, what would t of 0 be? Okay, there's a theorem that we saw in the section that pretty much says that if t is a linear transformation, t of 0 has to be equal to 0. So what we're going to do here is we're going to compute t of 0. We're not going to get 0, so I'm giving you the punchline. And basically what we will say is, well, if the transformation was linear, we would have got 0. Since we didn't get 0, the transformation cannot be linear. That's it. All right, let's do it. So, compute t of 0, okay? So t of 0, okay, which is t of 0, 0. Note that the domain is R2, right? That's how we know that we have 0, 0, but you can actually just replace x and y by both 0 because that's what the 0 vector is anyways. So that's how you get this. And the idea is quite simple, right? You replace you replace x with 0 wherever x is, and you replace y by 0 wherever y is, right? So as you can see, x is here and y is here. So in other words, t of 0, 0 gives you 1, 2, 0, 1. Multiplied by the vector 0, 1. All right, and then you can just multiply this with your favorite technique. So here, I'm going to use the linear combination technique. So it's the first weight times the first column. So here we're having the 0 over here, that this is the first weight, plus the second weight, that is 1, times the second column, that is 0, 1. Okay, then obviously, let's not make this calculation last too long. We have 0, 0 here. And then here we have 0, 1. Okay. So can I crunch the result over here? I'm going to see we have the result 0, 1. Okay. So in a single line, we were able to see that t of 0 is not equal 0. So, and basically what you need to say is pretty much that if t was a linear transformation, t of 0 would be 0. And I will just say by that this is by a theorem that we have seen in class that you can take for granted. Okay. And there you go. Since it's not, t cannot be linear. And this is what you wanted to prove. And that's it. So if you computed t of 0, you got this. By the way, using this version of matrix vector multiplication is not necessary. You can use also the rule that we used. I don't know how it's called, but the column row rule. There you go. That's how it's called. You can also use that to compute the product. As long as you get this, as long as you state that it's not the zero vector, and that you have that kind of sentence, right? That it cannot be linear, because if it was linear, we would have got the zero vector. It's a proof pretty much by contradiction. I hope this was helpful. See you in the next video.